Project Revolve Spring 2019 for Dr. Raymond. I'm Neerajs.
I'm Julio.
I'm Lissette.
And today we're going to be talking about our project. So the first thing to talk about is where we wanted to solve a problem. We noticed that when shelves are at the bottom location, people with back problems aren't able to easily access them, or just in general, it's a lot easier if all the shelves were within an arm's length.
So we did this with a little bit of inspiration from our foreign friends over in Europe and Japan. Over there, it's very densely compacted, and one of the biggest issues they have is parking. To solve this issue, they have parking structures that go vertically, so they're like elevators for your car, but in our case, they're rotating shelves. Next, we're going to talk about how we actually drove these rotating shelves.
So we created a 4-bar mechanism which will be driving our rotating shelves, and it'll be a foot crank.
I'll talk about how we actually designed our 4-bar mechanism. So this is our foot crank, and we had to start off with some constraints. So one of the constraints was that this had to be 6 inches long and start off 45 degrees from the ground. This would make it the most comfortable for anyone that would be driving the mechanism. We also estimated the diameter of this output shaft to be roughly 5 inches long, and with that information, we did a 2-position synthesis to actually determine the length of our coupler.
The next one of the 4-bar mechanism, one of the most important things is a ground link. So in order to ground our 4-bar mechanism, we have these 2 wooden pieces that are screwed into the bottom piece of our chassis, very rigid over here. And so these are held and secured with 90-degree L brackets, and then that is then mounted to another 2 90-degree L brackets to then ground the entire mechanism. Next, the most important thing was having a structure to house all of our shelves, so we just went with 4 aluminum stock square pieces, and then to give our structure some stability, we have 1-inch flat stock going across.
From this angle, we're going to be able to see clearly how our 4-bar mechanism is supposed to rotate. So Lissette's going to start rotating the outer shaft from the other side, and we can see our foot pedal going up, and going up, going up, and then this is when we would be pressing our foot downwards, and the shelves are still rotating, and now it's at its bottom position again, and it's being driven back. So there are a couple issues with our design right now. As you can see, one of the shelves just flipped over, but we will talk about those next.
So this is our mechanism in action. Unfortunately, due to some complications, we are not able to control it with just our foot. We will talk about how we would want to fix these later in the video.
As you were able to see, our foot crank doesn't exactly work as we would want it to. When it reaches this point, the transmission angle is actually not ideal. To overcome that, we'd have to redesign our whole entire foot crank. Another thing we could have done is add a foot strap, so that way we'd be able to pull the mechanism back, and then once it reaches the top, push it back down. Another thing we should have done is made the actual pedal itself larger. We should have made it a lot wider so that our foot could cover more surface area, and we should have made it a little bit longer. Another thing we now notice that we should have done is that we should have made the coupler 2 plates.
That you probably saw earlier was that our shelves, once they reach the top of its rotation, they flip over, and that's mainly due to the fact because our gears are not wide enough at the top. So one improvement we would make, which is a really easy improvement, is just buy bigger gears, probably an inch and a half bigger, and that should solve the problem.
So if we were to redo this project, one of the biggest things we take more note of is our budget. For instance, these square stock aluminum tubes alone cost $17 a piece. In addition, we used these kinds of clamps over here, which were about $17 for a pack of 4. So if we were to redo it, we would reduce the number of collars we use, and then also consider using PVC, because as we used for our upper brace, PVC is a very durable material, and it would have gotten the job done perfectly.
Yep, and to kind of conclude on all of that, we could have started with the smaller prototype, probably saved more money, and most likely gotten it to work 100%, but we wanted to be a little more ambitious and have like a real working model. In conclusion, I think we can all say that we learned a lot from this project. We know what we can improve, we know what didn't work, we know what did work. So if we had a couple more weeks, I think we would be able to get this project 100% functioning.